This video is on key features of a function. We're going to be doing example 1. It says the following graph describes a function of a cell phone cost by the number of months. Use the graph to answer the following questions about the function. We're going to identify the independent and dependent variables. So independent and dependent. We ask ourselves, if we're talking about number of months and the cost, would the number of months depend on the cost of the phone, or would the cost depend on the number of months you have the phone? The independent variable is generally the one that you can change, and it makes sense to change. The dependent variable is what is affected when you do change the independent variable. So if I change the cost, is that something that's easily changeable? What the cost is? Or would it be easily changeable the number of months that I have the cell phone? The independent variable is on the x-axis. So in this case, since we have a graph, we can also see that the number of months would be our independent variable. The number of months would be our independent. This one is easily changeable, and it makes sense to be independent, and it's generally time is also helpful in knowing it's going to be independent. Not always, but it is a good indicator of this will probably be independent. Dependent is what is being changed because of your independent variable. So the cost depends on how many months you have the cell phone for. So the next question says, after how many months would the cost of the cell phone be $425? So we're looking for how many months. We need to know how many months this is when the cost of the cell phone is $425. So if we're looking at $425 on the cost is on the y-axis. Here's 400, here's 450. So the line is already at 425. So if this is $425 and I move over to the actual function itself, I come to the point right here. Then I use that and go down onto the x-axis to determine how many months that is. That's at the 9. So it actually takes 9 months. After 9 months, the cost of the cell phone would be $425 months. Apologize. So on this next one, after how many months would the cost of the cell phone be $225? This time the line's not on there for us, so we need to do that ourselves. So we know that the cost is $225. That's on our y-axis. So if we go here, 100, 200, 250. So 225 would be in the middle. I'm going to use that, draw a line over to the graph itself, then I can stop, and then I'll use that to go down to figure out the amount of months. It's at 4 months. How much should it cost after 6 months? So this time we have the number of months. So I'm going to start on the x-axis and go to 6. I will go from the 6 and draw up until I get to the function itself. I'm at the point, and then I'll use that to go over to the y-axis to get an actual amount. That's 300. So it would cost $300 after 6 months. We're going to estimate the y-intercept and explain its meaning in the context of the problem. So estimate the y-intercept. We're not going to get an exact amount, and that's okay. We're going to try our best. I'm going to zoom in a little bit. So our y-intercept is when the graph crosses the y-axis. So it would be right here. This would be our y-intercept. So it's a little bit above 50, but it's not to 100 yet. So I would probably say it's an estimate of about $70. So in the context of the problem, no months have happened yet. So if we remember, this is the cost of the cell phone. So we could say that the initial price, the starting value of the cell phone is $70. The initial price of the cell phone is $70. Because that's what the y-intercept tells us. It's the starting value. Find the interval over which the cost is increasing. So as the x's increase, when does the y's increase? So if we look at 0, this is our starting value. As I'm moving to the right, my line, I'm just going to follow my line, and it is going up. And it never comes to a turning point. So the graph is actually always increasing. So we can say, so for the interval, there is no actual interval for this because it never stops. So when we write this, I'm going to write out in words first. The function is always increasing. Since we're starting, I'm going to put that in parentheses, starting at 0 months. So we can say, therefore, it is increasing. So we're going to write an inequality for this. Since it has a starting point, but it never actually stops, we're going to have one inequality. We're going to say, remember, it's always as the x's increase. So as the x's are moving, so it's starting at 0, but it's going to go on forever. So we would say as x is greater than or equal to 0, it is increasing. So when it says find the interval over which the cost is decreasing, well, as we can see, it never comes to a turning point and it never starts coming back down. So we can say that the function is never decreasing. The function is never decreasing. Next is asking for us to describe the domain of the function. Now, if we recall, the domain are the input or the x values. With this context, we do not have negative months. So the first month we have is 0 months. So we cannot say that it also includes the negative months because that's negative time and we can't go back in time. So the domain of the function is all of the x values that are actually being used. All of the x values to 12 are going to be used, but it can include the 13th, 14th, 24 months is 2 years. So any month, as long as it's above 0, so 0 and above, we actually have those in our graph because it does keep going because of our arrow here. So the domain of this function is, since it's the x's, all of the x values it's going to be greater than or equal to 0. Because the domain never goes into the negative. The x values never go into the negative. When it asks us to describe the range of the function, if we recall, the range are the y values of the function. So if we look at the range, so we need to find our first y value. So I don't have any graph down here at the y value of 0. So if I move up, my first y value was around that 70, like we said earlier about the y-intercept. So we would have the 70 here, and the y values continue to go up and never decrease. So the y values start at 70 and continue to move up. So we will say that the range is y is greater than or equal to, since it started at 70 and it kept going.